The question 13 says, convert the following degree measure to radian measure. So by definition, a radian, a lot of times will a radian measure can be defined by the arc length divided by the radius. And this ratio will typically turn into a decimal. So if I look at a circle, if I start here, if I go all the way around the circle, that's called the circumference. That would be an arc length. A radius goes from here to here. So by definition, I could say that circumference is equal to 2 pi r. So what I can do is for a whole circle, 2 pi r represents the arc the arc length. And if I divide by r, notice that the r's divide out and I end up with 2 pi. So what I picked up on then is in degrees, a full circle is 360 degrees. So we could say then is 2 pi radians is the same thing as 360 degrees. So a lot of time we don't even put the rad there, we just simply put 2 pi. So 2 pi is understood to be in radian measure. So 2 pi radians equals 360 degrees. Now if I divide both sides by 2, we can get this down to pi radians, if you will, equals 360. I'm sorry, half of 360 would be 180. So pi radians is equal to 180 degrees. Now, remember, pi is about 3.14. So 3.14 radians is about 180 degrees. And if I divide those both by 2, 3.14 divided by 2, I could say 1.57 radians is about 90 degrees. So we have some things here we can kind of use as a guideline. Now, if I do half of 90, if you will, we'll do this one more time. If I divide that by 2, 0.785 radians is about 45 degrees, if you will. Now, what they gave us is 33 degrees. So 33 degrees, here's going to be my initial side, and I'm going to rotate what I think is about 33 degrees, which is about probably here. So that's going to be my estimation. So this is 33 degrees. What I want to do is instead of saying 33 degrees, I want to convert this into radians. What I can do is I can use this conversion factor here. Pi radians is equal to 180 degrees. So what I can do then is I'm starting with 33 degrees. And what I can do is multiply by the conversion factor. Since I want to convert to radians, I want the pi radians in the numerator. So pi rad over 180 degrees. So notice how the degrees will cancel out. So what we have then is 33 times pi over 180. So if we multiply that math out, that's going to be in radians. So 33 times, and I usually put this in parentheses. So pi is actually located above the up arrow. So second up arrow divided by 180 would be my conversion factor. And that should convert the degrees into radians. So I'm getting like 0.575. So I think this is around to the nearest hundredth. So 0.57, 0.58. So this would be 0.58 radians, if you will. So notice that our conversion factor is going to be this pi equals 180 degrees. So pi radians is going to be the same thing as 180 degrees. So remember, radians is going to be the arc length divided by the radius. So, but since all circles are similar, what we can do is actually generate tables out of all this, and we don't have to do all this math because circles are actually considered similar. So ratios become equivalent, doesn't matter what the radius is. So, that saves us a lot of math. But if I wanted to make up a radius here, I could actually do this math, and it should give me 0.58 radians. So, uh, if we just want to play with that for a second, uh, you probably want to hear all that just this time. So, email me if you want to see a little bit more on this, because that's going to take a little bit more than a few minutes to do. Also, if you want a quick way of doing this, if you change the mode on your calculator to radians, so if I come down here and make sure this is highlighted, if degrees is highlighted, then come over and click enter and highlight the radians. So make sure it's the dark one, not the light one. So if I quit that mode, what I could do now is I could type 33 degrees into my calculator. And if I hit enter, since my mode is in radians, it should turn it into radians. So your calculator actually can do the conversion factor of degrees to radians as well.